special relativity. So I say some basic idea, not the mathematical thingy or everything, but just some basic idea of special relativity. Just concept of relativity and just what is in special. Relativity is how to communicate with other people in very basic notion, and special means in flat space-time. So we'll not go some curved space-time, we'll just say in Minkowski flat space-time thingy. So understanding special relativity is understanding the property of the space, flat space, and how to transform the physical quantities in flat space-time and how nicely you can do it. So to do it, let us say there is some observer A and B. The point is that each observer says that I'm not moving, I'm just sitting here. So more concretely, A and B are some observers sitting on a sofa floating on the universe. In A's view, A is stationary. More precisely, A is not moving. That's what we call A's view. And A wanna describe how B is moving. He can use equation, he can use vector, he can use even table, whatever he want. As much as you know mathematics, you can have more tools to describe how to move B. Today I wanna do basic thingy, so I just draw graph. So in A's view, I can draw graph with time, one is position. Let us say x means direction of moving right. And when A's view, B was moving to the right. Oh. So B is moving right, like this. At t equals 0, it means when A starts to move, check. In fact, B can move from the backward, and t equals 0 is this time, and B is moving this direction. Then A describe B's motion with some straight line with each inclination 1 over V. Let me draw again. I want it more narrow. Okay, again. Yeah. So let us think it is straight line. So it is inclination is 1 over V. And this is B. It is this blue line describe B. And A have his own time and X. And how about B? In B's view, B say, I'm not moving. So B is not moving. That's what we say B's view. In A's view, B was moving to the right. But in B's view, B is stationary. So in A's view, if A is here, in fact, in B's view, A was going to the left with the same amount. So if B moves 1 meter right, okay, 1 meter to the right, 1 meter to the right, then in B's view, A is going 1 meter to the left. So in B's view, he draw also figure, he draw graph to describe A's motion. So B will say, to distinguish A's time and B's time, let us put prime on B's time and B's position. B say, he is moving left. So because A is black, let us draw black line. So A is moving in this direction. And this slope is 1 over V minus V. This is what we call how we describe A's motion in B's view. So then in this figure, you can see that we draw time and position are perpendicular. And what you need to understand how to draw this timeline. Timeline, when you draw it in ace view, let us go ace view again. Async, if something is with me, let us say some A is holding some ball, this ball is always x equals 0, and in fact T line is exactly x equals 0 line, right? Then how about B? In B's view, if B is holding something, if B is holding also something, then it's B's line, x prime equals 0, and every x prime equals 0 stays in this line. So in what is T prime axis? It is x prime equals 0 line. So you know how to describe x prime equals 0 line and x equals 0 line. Then this red thingy B is holding on his hand is moving with B. So in A's view, this red line also stays here, and in fact this is exactly x prime equals 0. So it is in fact we draw this blue line, and this blue line will become T prime. So this blue line will become T prime. Okay, then in a similar view, if A holds some red triangle, this triangle will stay with A, and this is x equals 0, and this black line is moving with A, and in fact this is A's T line. This is what we can find. So we always have a T and T prime line in a graph. So A can say, hey B, I know what is your T prime line. It is just this line. B also can say, hey, I know what is your T line. T line is this black line. So now they can communicate each other what is their T line and T prime line. Next question is, then what is x and x prime line? Of course, in a similar manner, you can say, oh, x prime is, okay, x prime is what? Oh, sorry. X prime is just the line with the T prime equals 0. Similarly, x is x prime equals 0. T is 0 line. That is true. This is how you draw x line and x prime line. The question is, now you don't have some clear notion what is T is 0 or what is T prime is 0 in other place. You need some criteria to choose what is T line and X line. Usually when we run special relativity, we also run Galilean relativity. So let me copy and paste this other line, and let us let me describe first Galilean case because it is traditional. Galilean relativity. It is before Einstein, I say. Galilean relativity says that what is, or Newtonian relativity, what is x prime line, x line, or what is t equals 0, and the answer is, they say, there is some absolute time. So let me write some nice. There is some absolute time. It means, what is absolute time? Means that if this guy says t equal 1, so x is t equal 0 line, and then what is t equal 1 line is something here. T equal 1, what is t equal 2? This line. And the question is, what is t prime? And it is absolute, time is absolute. So it means that t prime equals t. So this was in fact t prime line, this is t prime line, and t equals 0 was in fact t prime also equals 0. Here also t equals 0 is same line. So this line is also t equals 0. So in fact it was not only x, it was also x prime line. Similarly, this is not only x prime, this is also x line. So this is what Galilean relativity says. So you have two different observers. Let me just draw only axis alone. So you have you have this t prime, t and x line, or t prime x prime, t prime x prime line with t in here. T prime line is something like this, and x prime line is this. And here, t prime line, t line is this, and x line is this. Then you describe some other particle. Let me say some green circle is moving some randomly. Then it can be, in A's view it moves this way, in B's view it moves this way. So let me draw below. In A's view it is moving some this direction, and in B's view it moves some this direction. You can see their angle change it. And how it change it? It just change it because when you move this to here, because you are moving arrow to here, you need some transformation. And how you do it? You can use Galilean transform. But what I wanna say is today is that because we wanna focus on just special relativity, there is some angle change. So everything changes with a similar manner. So everything always moves a little bit this direction when you change t prime. So it means the velocity goes slower. So if it moves u, its slope is 1 over u. Its slope becomes u minus v, 1 over u minus v, something like this. So its slope, it is simple, just graph moves a little bit leftward. It is much more intuitive, just you can think of stretching or extending, widening the lines. You just move axis. Then how about non-Galilean case? In our case, we want to know what happens in special relativity. So let me go to the special relativity. So I copy this again and paste somewhere here, and let me see what happens in special relativity. In special relativity, I just write SR. In SR, what is different? The difference is that not you don't have any absolute time, but you have light speed is universal, or light speed is universal. It means if you send some laser, let us say now the laser is moving with velocity c, but because making c is very big in MKS unit, we will use some special unit which have c equal 1. Then what is this right in t and x? This is just straight line with velocity 1, so its slope is 1. And from the special relativity, what it says is in t prime and x prime, it is also velocity 1. Then slope is 1. Then the question is, what is the best choice you can make to make this slope is always 1? The simple answer is you have this and you may want to make some same angle. That is how you make the straight line, same slope. So if you have a slope 1, it means that because x prime and t prime axis is 90 degree, they should be in the middle of it. And in the middle of it, it should have this direction. X prime should be here. Similarly, you wanna have same angle between here and here, something. So your x-axis should be something here. So this is x-axis. So now you see what is the difference in Galilean relativity, because absolute time forces you to draw x-axis in the same with x prime axis. But when light speed is universal, you give up absolute time, and what you choose is just making angle between t and x should be the same. So then you have different axes, and this x-axis is t equals 0 line. Again, this is t equals 0 line. So x-axis, this guy, maybe I choose x prime. X prime, this guy is t prime equals 0 line. Then because t prime equals 0 is this direction, and what is t equals 0? Here, t prime equal 1, so t is t prime equal 1, t prime equal 2. So here, t prime equal minus 1, and so on. So that's how you get something like simultaneity broken, because in two events, when you do special relativity, you always choose 2 points. Let us choose one here and the other here. Okay, the other here. So this guy and this guy happens same for the A's view, but in B's view, it is something like t prime equal 0.5 minus 0.5, this guy t prime equal minus 1.5. So each point has different coordinate in different observers. In other words, its time coordinate is different for the different observers. So it is very natural thingy happen in special relativity. So this is, I think, the most basic thing you need to understand about the special relativity as a conceptually.